Now let's look at this figure 20-44 from Stallcup's Electrical Design Book, Volume 2. And before we get into it in more detail, let's just take a look at the notes and information the notes provide. In Note 1, it's a rule of thumb method shown. It gets us to a point to where we can actually apply all of 240.92e. And then secondly, the Note 2, the current protection characteristics of primary device shall be met per IEEE C37.91 and size to protect the conductor windings and circuit conductors. And then Note 3, the overcurrent protection relaying shall be permitted to be used to limit the load to the ampacity of the conductors and to protect the secondary output of the transformer in accordance with 240.100A as in Apple 1 and 240.100B and C of the NEC. Note 4, the relay power center will open the devices in the switch gear. And then finally, we'll look at note number 5 in the illustration. And it states for overcurrent settings of the overcurrent protection device, see 450.3 informational note 1 and 2 for guidance. Now, those are our notes, but now let's look at the information that's provided in the switchgear here. And we have a primary, which is 4160 delta connected supply. The overcurrent device limits the load to the ampacity of the conductors and 240.100B and C. The wiring methods is run overhead so we can get a outline of those in 300.17. And then as you can see, that's a delta connected primary and a delta connected secondary. And it's an ungrounded system in accordance with 250.130B. The secondary voltage is 480 volt supply. We have 500 kc mil, 380 amp each conductors, is outlined in table 310.16 in the 75 degree column. We're terminating in a main overcurrent device, is outlined in 230.70B, 240.100A1 and 240.100A2, as well as 240.100B and C could be used depending on voltage. Now, if you notice in the illustration, the overcurrent device is 350 amps and the equipment is 400 amps. The service equipment there, not service equipment really, but the sub-panel equipment. Over 1,000 volt wiring systems above ground, we'd go to 377 for the wiring methods. And if you're underground, just go to 300.50. And those are outlined so that you don't have to go all through the code looking for your type of wiring methods that can house these conductors. Now, we know that new Article 311 has the medium voltage Article 328, and it has tables sizing cables and conductors and raceways and so forth. But to get the components in a high voltage switchgear, which you see to the left of the illustration at the top, you go to Article 490 to build your protective scheme, uses circuit breakers, fuses, selecting a switchgear, panel board, and so forth. When I say panel board, you know, switchboard. Now, we pick that information up, and now when we look at the calculation, let's look at Quick Calc 1 in the illustration, and notice we're applying 240.92E. And we take 4160 divided by 480, and that's an 8.7 to 1 ratio. And if we took 8.7 and divided it into 380, we come up with 43.7. And that would round down to a 40 amp overcurrent protection device that we would use, see. And then in the quick count 2, we're applying 240.92E, and basically 4160 divided by 480, again, we're showing the ratio 8.7 to 1. And if you took 8.7 into 40 amps, or times it, you'd come up with 348. So we could round up there to 350 amp CB that protects the 380 amp conductors at the equipment. Now, looking at the quick count 3 now, we're applying 240.92E for a 3-wire delta to a 3-wire delta. Step 1, 240.92E, we're finding the ratio amp. So we would take 480 divided by 4160 times 380, and that'd give us a 43.8 to 1 that we would have there. So the solution is the 40 amp overcurrent protection device on the primary can protect the secondary conductors. Now, by applying all the requirements and 240.92E, then the secondary side showing those conductors seems to be, they could be any length as long as you apply that. Now, I figure 20-44 is simply stating the primary protection of a transformer shall be permitted to be used to protect the secondary conductors, provided the primary protective device current protection characteristics multiplied by the maximum effective primary to secondary voltage will effectively protect the secondary conductors. And that's what we're kind of showing in this figure, is the protection by primary overcurrent device in accordance with 240.92E, and then you could see we would have enough fault current, because we've already done that in an illustration to show you. So we pretty well then know we can trip that primary overcurrent device. Now, if you want to see how that's done, how we would size to protect the secondary by the secondary ratio, providing amount of short circuit current that would trip the primary device, just look at the figure 20-41, and you can see how that is done. So these two kind of go together to me, figure 20-41 and 20-44 in Stallcup's Electrical Design Book, Volume 2, and that's what our figure 20-44 as well as 20-41 is illustrating.